Hello everyone, this is Dr. Ali, and in this session we want to solve another recursion function that basically we want to calculate the x to the power of n using recursion manner. So yeah, last session we solved the factorial, and we know that we need to have actually the base case. If you remember these slides, we said there is one or more base case and one or more basically recursion steps. So for the power, we also need to follow the same guidelines that we know that the x to the power of n is equal x times x to the power of n minus 1. This is the something that we know from calculus is correct. For example, 2 to the power of 5 is equal 2 times 2 to the power of 4, right? So this is the recursion part. And then for the base case, we know that the any number to the power of 1 is actually the number itself. 10 to the power of 1 is equal 10. Or you could just change it to 0. I mean, any number to the power of 0 is 1. That's also another. If you like it to put it 0, then it should return 1. But for yeah, so we have those two principles that we needed to find out about here. So we know that the base case, we know that the recursion part. So let's see the graph, something that we saw for the factorial, but now we want to see it for the power to see how it works. Let's say we want to calculate 2 to the power of 4. So we call this function with the base 2 and the power 4. So it comes here, it says 4 equal 1, no. So call the 4 times 4 to the power of 3, right? So basically it says, I don't know what is 2 to the power of 4. If you give me 2 to the power of 3, I know how to calculate 2 to the power of 4 because I only need to 2 times 2 to the power of 3. The same thing for 2 to the power of 3. And when it reaches to the 2 to the power of 1, we know what is the value for this. Why? Because it hits the base case. And if we know that the base case is x, which in here is 2 basically, 2 times 2 is equal 4, right? 2 times 2 equal 4. Now that I know what is the 2 to the power of 2, based on this graph, I can calculate 2 to the power of 3. I only need to say calculate this. 2 times 4 is 8. And then 2 to the power of 4 is equal 2 times 8. Then we have the 2 to the power of 4 by just trace back of the graph. So I just copy paste this code that I wrote and I put it in the GitHub, and I will share the link with you guys if you want to double check it yourself. Let me run this in order to evaluate this is actual working, and there's no issue there. So if you compare, let me like resize this a bit. And let me go back to this graph. Yes. So it says you wanted to calculate 2 to the power of 4, but you needed 2 to the power of 3. You needed 2 to the power of 2 and 1, based on what I explained here. And now these 3 are the trace back. It says, okay, we know that what is the 2 to the power of 2 is 4, right? Is equal 4 here. 2 to the power of 2 is 4. Then if I know this, then I know what is 2 to the power of 3 is 8. And then 2 to the power of 4 is 16, and then it will print 16 because we have another print statement at the end. So that's it for today, and basically for this example of power. But let me give you a little bit introduction for the next example we want to solve. Is a Fibonacci numbers. What is Fibonacci? Basically is a sequence of the some values that starts from 1 and 1, and then the next value in the sequence is calculated by adding 2 previous values in the sequence. For example, 2 is calculated by 1 plus 1. 3 is calculated by 2 plus 1, and so on. So when we say, what is the Fibonacci of n? It means, what is the nth value in this sequence? For example, if this is 3, we want it to return 3 because it's a start from 0. 0, 1, 2, 3. The third, or the basically starting from 0, what is the value in index 3? Is 3. What is the, if the Fibonacci of 4, we expected it to return 5, and so on. Here we have 2 base cases. One, when the index is 0 or index is 1, we return 1, because these two, we know what is the Fibonacci of, at the index 0, and what is the Fibonacci of index 1. So these are the base case. But if none of these two hit, and we know that the number is always positive, so we can calculate the Fibonacci for that specific number by adding two previous Fibonacci. You see, I call the same function twice, right? With the smaller parameter. So if we start with n, now I call in the same function with n minus 1 plus n minus 2. So these are important. And now, unlike the previous sessions or previous examples that we always have one actually base case and only one return, here we have two base case and two basically calling of the function. The graph that we have so far was just a line, right? But here in this example, the graph for this Fibonacci is actually a tree that we will see in next session, but just be aware of that. And just one question that I have for you guys is, what will happen if I just get rid of one of these base cases? Imagine same code, but it doesn't have this if else statement here. What will happen? What caused the issue? We will see this next session. So that's it for today. If you have any comment, concern, leave it down below, and have a great day, everyone.